Hello and welcome to the introduction for this course. What you should know before you take this course. This is a beginner's course, so all you need to know really is to know your way around your computer. That should be sufficient to follow along with the course. Who should take this course? This is an absolute beginner's course. So it's designed for people who have never programmed before or developed before, also for anyone who wants to learn something new. What will you learn on the course? The course is practical and it's hands-on, so there are few projects to create. So we'll start with the installation of Python, and then we'll progress with some basic introduction to programming in Python. So you'll learn about variables, arithmetic functions, and so on. Then we'll go on to introduction to Tkinter. Tkinter is a Python module that is used to create GUIs. GUI stands for Graphical User Interface. Then we'll start creating the project. We'll start off by, we create a digital clock and then a countdown timer. Countdown timers are very useful. You can use that to count down to various events. We'll create a calculator, a weight conversion tool, a times table generator that will generate times tables, a random number generator, a number guessing game. We'll also have a bonus application that will be used to detect and remove vowels. The format of the course is video based and the duration is 4 hours. Thank you for watching, and I look forward to seeing you on the course. Bye for now. Hello, let's take a look at the projects we are going to create for this course. Project number 1 is going to be a digital clock. So we are going to be creating something like this. Project number 2 is going to be a countdown timer. Countdown timer are very useful to count down to various types of events. So this is the countdown timer. So we're going to be creating something like this, where you will set the end date for the type of event you want to count down to. Project number 3 is going to be a calculator. We are going to create a calculator like this, where we can do basic additions, multiplications, subtraction, and division. Okay, so project number 4 is going to be a weight conversion tool. So this is the weight conversion tool. So you enter your weight, for example, in feet, and you calculate it and convert it to meters. Project number 5 is going to be a times table generator. So this is what the times table generator looks like. You enter a number in there and click on times table, and it will generate the times table there. So if I click on 4 and click times table, you can see it generates 4 times table for me. So it can generate from 1 to 12 times table. Project number 6 is going to be a random number generator. So this is how the random number generator works. So you specify a range of numbers and it will generate numbers up to that range. So if I run the application here, if I go run, it will just generate random. You can see here it's generated a random set of numbers, which will tally with the range that you've specified. Project number 7 is a number guessing game. So this is how the number guessing game works. You specify a number. In my case, I specified a number from 1 to 70. So you need to enter a number. So if I enter 30, press enter, it tells me the number is too low. Say 80, say the number is too high, 60, too low. So you keep going on until you guess the right number. There's also a bonus project which is called vowel removal. So this is how the vowel removal works. You type in a message. For example, if I type in welcome and press enter, you can tell it removes all the vowels and gives you an output. Hello and welcome to this lecture. In this lecture, we'll be having a look at what is Python. Python is a case-sensitive, general-purpose, object-oriented programming language. By case-sensitive, I mean, for example, if you've got an object called Apple in uppercase and an object called Apple in lowercase, Python will treat them as two separate objects because one is an uppercase and the other is a lowercase. Also, Python is often referred to as a general purpose language. By general purpose, I mean it can be used to do a variety of things, both big and small. Python is an object-oriented programming language. Object-oriented means it treats everything as an object. For example, in the real world, a car is an object, a person is an object, a teacup is an object. So Python treats everything as an object. By programming language, a programming language is a language that is used to communicate with a computer. Computers respond to the command you tell them to do. So in other words, you can make a computer as smart as you want to be. What a programming language is just a set of instructions to tell the computer what to do. For example, if you want to bake a bread, there are steps you will take in baking the bread. Computer programming is the same way. If you want a computer to do something, you need to give it a set of instructions to follow. Python got its name from the British comedy group called Monty Python. So these are some images of the guys from the Monty Python comedy group, and there are their names displayed on this image here. Due to its flexibility, Python can be used to create games. Also, it can be used to create statistical and visual data. Does all that. Python can also be found used in some of the most famous websites on this planet. You can find the software either being used to build them or used to run these famous websites in one way or another. For example, you have Google uses Python in its app engine. You've got YouTube. YouTube uses Python as well. Facebook uses Python in some of its internal scripting. Instagram was created by Python using the Django framework. Pinterest is another famous social website, also created by the Django Python framework. Then you've got things like Yahoo Map, also created by Python. And then we've got Reddit. Reddit is a famous website. It was created also using Python. And we have NASA. NASA, the space company, uses some element of Python in some of the work it does. You've got the music streaming company called Spotify. They use Python as well. You've got the storage company, online storage, Dropbox, where you can save and retrieve documents. It was created using Python. The Washington Post also uses Python. Disney and Pixar, the animation company, also uses Python in some of its animation. Python also can be used to control robots, and they are also used in speech recognition and face recognition. Also, the biggest survey website on the world, SurveyMonkey, uses Python. So these are some of the famous software companies that are either built using Python or are using some part of Python in running their software. In this lecture, we learned that Python is a programming language and that it is case sensitive. It is a general purpose language that can be used to perform a variety of duties or things. We saw some of the famous websites that Python has been involved in one way or the other. We learned that Python is an object-oriented programming language. It treats everything as an object. Python borrowed its name from the British comedy group known as Monty Python. Thank you so much for your time. Bye for now. Hello and welcome to this video. In this video, we are going to download and install Python. The link to the Python website is displayed on the screen. So I am now on the Python website, which is python.org. So click on download. When you click on the download or you hover your mouse over the download option, you will see the download for your operating system. It should automatically detect your operating system. If you are on a Mac, you should see the option for Mac displayed. If you don't see it displayed in this area, just click on it here from the menu that says Mac OS X and just follow the on-screen instructions. So I'm on a Windows, so I'm going to go for this option here, Python 3.62. So I'll click on that to begin the download. So once the download is completed, on the bottom here, just double click to run the installation. Click on Run. So it tells you where Python is going to be installed. So if you want to take note, this is the location where your Python installation is going to go. And it tells you here it's going to include the idle. The Python idle is kind of like the interactive shell where you can type in command. It also includes pip. Pip is what you use to run various Python packages. The pip is actually a package management system used to install and manage software packages written in Python. It's a bit like the Nodes package manager npm in Nodes. There's also a box here that you need to check. So what that does, it will add Python to your environment path for your system. So I strongly recommend you click on that. So click add, and once you've checked that, just click on this area here that says install now, and that will begin the installation. If you get a prompt from your antivirus or user account control to accept the installation, just click yes to accept, and the installation should progress. Once the installation is complete, you'll see a message that says setup was successful. You can then close and exit Python. So that's it for this lecture. We have successfully downloaded and installed Python for Windows. Bye for now. Hello and welcome to this lecture. In this lecture, we'll be looking at the Python idle. The idle stands for Interactive Development Environment. It is an environment that you can use for learning. It consists of two main windows. the edit window, and the shell window. I have heard people say that the idle was also taken from Eric Idle, which is one of the members of the Monty Python comedy group. It's a British comedy group. Their name was used to name the Python programming language. So the group as a group is called Monty Python. There is a member of the group called Eric Idle. Some people say the idol was named after him. I'm not sure, but that's what some people say. So that's an image of the Monty Python group, and that's Eric there, Eric Idle. This is a more maybe recent picture of the Eric Idle. So some people say the idol is named after him. Let's have a look at what the idol looks like. So go to your start. If you are on a Windows computer, go to start, all programs. You should see the Python 3.5. If you click on that, you should see the idol there. So just click on the idol and it should load up. So this is what the Python idol looks like. It consists of two main windows, the edit window and then the shell. So this is the main shell. This is where you would experiment when you are writing Python code. It is a useful learning environment whereby you're writing, if you're writing little chunks of code, it's interactive, so you can see the output straight away. The other window is the edit window. So to access it, you go to File and go New File. And so this is what the edit window looks like. So when it opens up initially, it has the label Untitled. But when you save it with a name, then that changes. You can see there is a slight difference in the menu options of both windows. Both of them have got File, Edit. If you notice, this one, the shell, has got the shell. It's got a debug. Debug is a way of testing out your code. It's got Options, Windows, and Help. So this has got the Run here. So the menus are slightly different within both windows. I'm just going to minimize the edit window for now so we can focus on the Python shell. The Python shell is an interactive window and it acts as an interpreter. So it will interpret what you type into a format the computer can understand. So when you've got this three sign here that looks like right angles, if you got these signs here, it tells you that the Python shell is waiting for a command. So it's waiting for you to do something and it will respond. So let's do some basic maths. So let's do 3 plus 4. And then if you click on enter on your keyboard, you should get the result. There you go. 3 plus 4 give you 7. Let's do a minus this time. I'll do 6 minus 4 and click on enter. It gives me 2. Let's do a times this time. I'll do 9 times 6. The times in Python is represented by the asterisk symbol. So if you click enter, it will give you the output. So these are just basic arithmetic calculations that you can perform using Python inside the idle using the Python shell. The Python shell is referred to as the interactive mode. It's mainly used for testing, learning, and trying small things very quickly where you can see a response. The edit window, on the other hand, is used mainly for scripting, where you want to script or write proper code that will do something very useful, and a code that you can save and run later. If you want to do that, you would be using the edit window, which is this screen here. So this is where you would write your proper code or instructions for the computer to follow. And then when you save the file, you save it with a .py extension. So something like if you write in hello computer or something like that, when you're writing text in computer language, you need to surround it with quotes so that the computer can understand. So if I was to save something like this, you save it as, I'll save it, for example, save it on my desktop, and I'll just save it as hello.py. py is the extension for Python, so that's it saved there as a .py extension. So if you want to write proper code to do stuff, it's best to use the edit window, and then you can save your files. You can also run the Python shell from within the edit window by going run and then Python shell. This was the simple hello I wrote in Python and saved. So this is how your files will look like when you're saving from the edit window. In this lecture, we had a look at the Python idle, which is an integrated development environment that you can use for learning. It consists of two main windows where you can work from: the edit window that you can use to write proper code, Python code, and then the interactive shell window where you can experiment and write little chunks of code. Thank you so much for your time. I hope the video has been useful. Bye for now. Hello and welcome to this lecture. In this lecture, we will be looking at some reserved keywords in Python. Reserved means they are words that belong to the Python language. The language actually uses these words, so we can't use the words to name our variables, to name our list, or to name anything other than what the language has reserved them for. So these are some of the keywords in Python. So we can't use any of these keywords. If I was to create a variable and use any of these keywords, Python interpreter will complain because they are reserved words and should not be used. So let's try an example and use one of them, and you can see. I'm going to try and create a variable and give it a value of, say, 20. If I click enter, Python should complain. It tells you here that invalid syntax because we cannot use that word. That is a keyword in Python. It is reserved, so we cannot use it. In this brief lecture, we had a look at some of the keywords reserved for the Python language. We also tried to use one of them, this def here, to create a variable, and the interpreter complained. So keywords are reserved for the Python language. So take note of these keywords. So when you're creating variables or lists, try not to use them because it will not work. Thank you so much for your time. Bye for now. Hello and welcome to this lecture. In this lecture, we will be looking at some very basic arithmetic operators. Python uses these operators to perform various mathematical operations. So the basic operators are addition, and that's a symbol, subtraction, division, and multiplication. So let's see if we can do an example of each of them. I've got the Python shell open, so I'll start with the addition symbol. So I'm going to add two numbers. So all you do, if I want to add, for example, 7 plus 7, and hit enter on my keyboard, and I get 14. So if I do 8, take away 3, enter, gives me 5. I do 8, divide by 2, I should get 4. And the last one is a multiplication. So if I do 5, multiplication is identified by the asterisk. So if I do 5 times 2, I should get 10. So we've been able to illustrate using each of the operators. You can also use the operator for a string operation. A string refers to a text. For example, I could say hot plus dog, and hit enter, and that should give me hot dog. So you can also use it for a string. So in this example, we went through some basic arithmetic operators. Try and play around with this so you get used to them. Thank you so much for your time. Bye for now. Hello and welcome to this lecture. In this lecture, we'll be looking at comparison operators. Comparison operators are used to compare things. For example, is 1 less than 2, is 3 greater than 2. So that's what they're used for, to compare. So let's try and create some examples. I've got my Python shell opened. So I'll start with the greater than sign. So I say is 6 greater than 5. If I click on enter, it should return true. So that's the greater than sign. Let's do less than. Is 3 less than 4. This should return true also. Next, let's do less than or equals 2. So say is 5 less than or equals to 5. So this should return true also. Oops, syntax error. Okay, I made an error with the syntax. Let's start again. It's 5 less than or equals to 5. Enter. See, because I left a gap, the interpreter got confused, thought I was trying to assign a variable. So I hit enter. You notice now it has worked now. So next we'll try the greater than sign, greater than or equals to. So say is 7 greater than or equals to 7. It should return true as well. Next, let's try an equals to sign. Don't forget, a single equals means you are assigning a value. So that when you're declaring a variable, you have to assign a value. That's when you use this single equals time. So if you want to know if something is, say for example, is 2 plus 2 equals to 4, you use the double equals to sign. So let's try that. So if I say 2 plus 2 equals, you notice I've used the double equals. If I use the single equals, the interpreter will complain because they will think I'm trying to assign a variable. So I say 2 plus 2 equals to 4. So this should return true also. See? Finally, let's try one more. Let's try the not equals to. So if I say is 8 times 8 is not equals to 4. That should return true also. All right. So these are examples of comparison operators, mainly used to compare things. Thank you so much for watching. Bye for now. Hello and welcome to this lecture on variables. Variables are used to store or hold a piece of data inside the computer memory. So a variable is also a name for a value. For example, you could have a variable called fruit, and the value could be an apple. A variable can store data with all kinds of values. It can store a number. You could have a variable called number and get it store numbers, or it can store a string. A string is also referred to as a text. You can store a variable called hello, for example. Variable values can change. Once you have defined a variable value, you can also change it. If you, for example, define a variable called fruit and you assign it a value of apple, tomorrow you can change that value to maybe an orange or a pear. That's what it means by changing the value of a variable once it has been declared or created. So variables always reference or point to a piece of data. This is a box, and say for example I decided to call this box maybe chocolates or something. So I will be storing all kinds of chocolates inside this box. So this box here will act as a storage container for chocolates. Say today I can put in maybe cream chocolates. Tomorrow I can change the value. I can change that value from cream chocolates to maybe dark chocolates and so on. So that's in effect what a variable is a storage container for a piece of data. To experiment or with variables, let's open up our idle. So go to Start if you're in Windows or Programs, click on Python 3.5 and then click on the idle. So we're going to have a look inside the interactive shell. So this is the Python interactive shell. Once you've got these three signs that looks like chevrons here, once you got that sign with the mouse with the cursor flashing, that means the shell is waiting for instructions. So to create a variable, all you need to do is just write the name. Say I want to create a variable called fruits. So I'll do fruits, and then you must give it a value, and you assign a value using the equals to sign. I call it and name it apples, for example. Notice I have enclosed the value in quotes because it is a text or a string. So in computer language and in Python, you have to surround text in quotes so that the computer can understand. So I have now created a variable called fruits and the value of apples. So if I type in fruits, it will display apples. So let's go to the next line and type in fruits. And if I click on enter, it will display apples because I've given it the value there. However, I can also change the value from apples to oranges by typing in fruits, and I'll set the value to oranges and then click enter. If I now call that variable fruits and click enter, it should now show oranges because I have changed the value. So once you have declared or created a variable, you can always change the value. So creating a variable means declaring it, and the equals to sign operator is used to assign a value to the. Okay, let's create something a little bit more interesting. I want to find the cost of 2 items. So this is how I would go about it. So I will create 3 separate variables. The first will be price number 1. I give it a value of say 40. I create another variable, price number 2. I give it a value of say 60. I create a third variable. I give it a value of total. And I'll make the total equals to price 1 plus price 2. So if I want to find the total price of price 1 and 2, I just need to type in total and then hit enter, and it gives me 100. So this is just simple ways how you can create variables. So variables are used to store values that you can change later. Thank you so much. I hope this introduction to variables has been useful. Try practicing within the Python shell, create some variables and play around with it. If you're going to create a variable that is a text, always remember to enclose the values in quotes. So creating variables and calling them. So when you create a variable, you are declaring a variable. When you're calling a variable, you just type in the name of the variable and it will display the value. Thanks so much for watching. Bye for now. Hello and welcome to this lecture on list. In this lecture, you will learn what is a list. You'll learn how to create a list. You'll learn about list index, how to reference an element from a list, how to edit a list, how to add to a list, and how to remove an element from a list. What is a list? A list is a kind of variable that stores multiple values as one. With variables, you can only store one value at a time. With a list, you can store multiple values as one. In some programming languages, a list is also referred to as an array. Lists are mutable. That means they can be edited. Once you've created the list, you can change it. You can delete elements from the list. You can add to the list. The list can contain numbers, strings. Strings are known as text, or they can contain both numbers and strings. They can also contain other lists. A list can also be referred to as a sequence of elements. Let's try and create a list. To do that, we need to go to our idle. So you go to Start, All Programs if you're on a Windows, and then click on Python 3.5, and then click on the idle. So we are going to create a list using the Python shell. So wherever you see the flashing cursor there, it means the shell is waiting for some instructions. I strongly advise you to type along with me. That way it will retain the knowledge you gain from here. So I'm going to create a list called fruits. So I'm going to type in fruits inside the Python shell. And then I'm going to give the fruits a value. So to assign a value to a list, you use the equals to sign, which is the assignment value. And then a list is identified by square brackets. So you place your list inside the square brackets. So let's type in the name of some fruits here. So I'm going to start with bananas. And then you separate each item in the list with a comma. Next, I'm going to type in oranges. Then grapes. And finally, apples. You have to make sure each element is enclosed in quotes because they are text so that the computer can understand them. So put quotes there. Notice as I put quotes, it changes to green. So quotes there. So quotes in between. And then another, oh, I've spelled apples wrong. Okay. A quote there and a quote there. So we have now created a list called fruits, and it has 4 items in there. 1, 2, 3, 4. Next, we're going to look at indexes, how we'll reference each element in a list. Say if you've got a list like this, for example, if I wanted to reference one of these elements in the list, I will be using the index number. Indexing means the way they are numbered in the list. So with Python, the lists are 0-based indexes. That means the very first element is labeled 0, followed by 1, 2, and 3. So just know the very first is 0. So if I wanted to reference, say, oranges from this list called fruits, this is what I will do. I will type in fruits, and then the square bracket, and then enclose the number 1, because the index for oranges is 1 and not 2. If I click enter, it should tell me oranges. So this is how you reference an element or an item from a list using their index numbers. Next, say we want to change an element in the list. Say if I wanted to change oranges to, say, kiwi, what I'll do, I'll type the name of the list, which is fruits, square brackets, insert the index. The index will reference this oranges here. Once I've done, and then I assign it a new value, and I type in kiwi. So this is now the new value for oranges. So to prove that, if I go fruits and then square brackets, type in 1 square brackets, it should show kiwi. So we've successfully changed the value of an element inside a list. So that's why lists are known as mutable. That means they can be changed. Say, for example, I wanted to add to this list. To do that, we use the append method. So we'll type in the name of the list, fruits dot append. Append means you are adding to the list, and then you give it, then you put the new value inside parentheses. And inside the parentheses, say for example, I want to include mangoes. So I type in mangoes. So this will now append to that list. So if I wanted to list the entire list, I'll come here and do a print function. I'll go print. And then type in fruits, which is the name of my list, and it will print all the elements in that list. Notice the mangoes here. This was an element I added on in the here using the append function. You can also remove elements from a list. Say for example, I wanted to remove this mangoes I've just added. You just go type in DL, which stands for delete, followed by the name of the list, followed by the index number. So this will be 0, 1, 2, 3, 4. So I'll type in 4 there and then hit enter. So if I do a print again, this mangoes should disappear from the list. Notice mango doesn't get displayed because it has been removed using the delete command. So in this lecture, we learned what a list is. We learned how to create a list. We learned about the list index, how to reference an element from a list, how to edit a list, how to add to a list, and also how to remove an element from a list. Thank you so much for your time. Try and practice using the Python shell. So go in and create several lists, try to append them and delete them. You can mix the list up with a text and a number, with a string and a number. Just play around with different values so you can get the hang of it. Thank you so much for your time. Bye for now. Hello and welcome to this lecture. In this lecture, we'll be looking at tuples. Tuples are like a list, but they cannot be edited. That means they are referred to as immutable list. They cannot be edited. With a list, you can make changes, but with the tuples, you cannot edit them. All right, let's create a tuple. Tuples are characterized by parentheses, whereas a list is characterized by square brackets. So let's create a tuple called, say, family. Then we give it a value. We use the equals to sign to assign a value. And then we put the values inside parentheses. Whereas in a list, the values are placed inside square brackets. So let's start. So you can use either double quotes or single quotes. So you say dad, comma, mom, comma, son, comma, daughter, comma. Anytime you're referring to a text is also known as a string. So wherever you're dealing with strings, you must enclose them in quotes. It doesn't matter, it could be single or double quotes, but you can't mix them. So if you start out with double, you need to end it with a double. Let's place one more member of the family. Let's place a pet. Put a dog there. So we have now created a tuple. Hit enter. So to call this tuple, all we need to do is type in family and click on enter, and it should display the list. All right, so it's displayed all the members of the tuple. With a list, you can change the values, but with a tuple, once it's been defined, you cannot change it. They are referred to as immutable list. That means they can't be changed. Thank you so much for watching. In this video, we had a look at what a tuple is. So try and create a few tuples yourself. Tuples can be useful where you are creating applications where you don't want the values or the variables to change. You can use tuples in such instances. Thank you and bye for now. Hello and welcome to this lecture. In this lecture, we'll be looking at how to use comments in Python. I've got my Python shell open. In Python, a comment is represented by the hash symbol. So wherever you see that, and any text that precedes that is ignored by the interpreter. So any code or text written where there is the hash sign, the interpreter ignores it. Let me show you an example. So let's type in hello world. And then enter. Notice nothing happened. It completely ignores it because it is a comment. Let's type the same comment without the hash. Enter. You say that it's returned hello world. Comments are useful. They help you describe your code to yourself and to others. Sometimes you may write code that you may forget the logic or what the code is meant to do. By leaving comments in between your codes, it helps you remember or describe what you're trying to do to yourself and also to other programmers. Hello and welcome to this lecture. In this lecture, we will be looking at how to slice a string. Slicing means cutting a string into smaller parts. Sometimes you may have a list and you may want to split the text or the string in the list. The way to do this is by slicing. So let's look at a simple example of slicing. I've got my Python shell opened. So I'm going to slice a text called strawberry. So to do slicing, you begin with the word piece, because you're going to split string or text in pieces. You type in piece equals to the text you're trying to split. I'll type in strawberry. So this is the text I am trying to split. The next line, you type in print, and then in parentheses you type in piece, followed by square brackets, and inside the square brackets is where you specify where you want to do the slicing. So I want to slice after the second character. So after 1, 2, I want it sliced. So I type in 2. Then you do that, and then you specify the second half where you want it sliced. So I want it sliced again after the 5th character. So it starts with a 0. So the S will be regarded as character 1. And then end the parentheses. So if I click enter, I should have a text called raw. Alright, so that is how slicing works. This is the simplest of the examples, so try and practice. The key thing is to know the position of the character of the text. Once you know it, then you can slice any text the way you want. Thank you so much for your time. Bye for now. Hello and welcome to this lecture. In this lecture, we will be writing a very simple program using the editor window. We will also learn how to save the program and how to run the program. So to begin, let's open up our idle. So you go Start, All Programs, click on Python 3.5, then click on the idle. Once you've got the idle open, go to File. We are going to be using the editor window. Go to File and go New File. So this is the window we are going to use to write our code. So for now, if you can just follow along with me, try and type as I also type the code. That way you will gain a better understanding. I will explain the code later. So let's begin by typing the word print. Okay, followed by parentheses. And inside the parentheses, we will write some text asking a question. So let's say, how many chocolates have you got? So we'll type in how many. Alright, so the question I'm asking in this program is, how many chocolates do you have? So we need to put a question mark before there because we are asking a question. When you are using text, you need to enclose the text in quotes. So you can either have it in double quotes or single quotes, but you can't mix the quotes. So if you start with a double quotes, you must end with a double quotes. So this is the first line of the code. asking how many chocolates do you have. And then in the second line, I'm going to declare a variable, and the name of the variable will be amount. And I want the value to be equals to an input. That means what the user will type in. So it will be equals to, you use equals to assign a value to a variable. So the value I'm assigning here is an input function. That means this variable will change, so you have to pass in whatever number you want. And then I will add another print function. The print is a function. I'll type in print. And then enclose parentheses. And inside the parentheses, I will write some text in response to the input that the user will key in. So I'll just say, wow. I'll just say, whoa. You have so many and then put a comma, and then I will add the response that the user will input in to the variable. All right, so that will be the response. So notice I've used single quotes here at the beginning of the text, and that's the end of the single quote. I've used an operator here, which is a plus sign, and I'm saying it will add this text plus whatever value I've passed into this amount variable. So this is just a simple program. So that's it. So we just now need to save the program. So I'll go File, then I'll save as. I'll save it to my desktop, and I'll call it goodies.py. The py indicates it's a Python file. So I click on Save. So I'll now exit that. So this is the file, the program we created. So to run the program, we need to reopen the idle. So click on Start, All Program, Python idle, wait for the idle to open. This is the idle, and we go to File, we'll go to Recent File, which will be this one here, and we click on that, and it brings this up. We now go Run, and then go Run Module. Okay, there you go. So this is our program saying how many, which is this first line here, which is the first print function. How many chocolates do you have? And in the response here, I can say 16. You can type in whatever number you like, and then hit enter. And then it says, whoa, you have so many, 16. Okay, it's in response to the second print function. So we have just run the program we created. Let me run through the code with you quickly. The first line of the code here is a print function. What this does, it tells the computer the words you want to show on the screen. That's what the print function does. The second line here was we declared a variable called amount, and we gave it a value of input. So what that does, it means that the input command will tell the computer that the computer user will need to put something inside this parentheses for the data value. The third line here, which is a print function, tells the computer to print the text in between the parentheses and also add the value, which is this plus, add the value of the variable inputs. That means whatever value you put in there, it wants you to add that to the text. That's the result here, which is this whoa, you have many 16 because I typed in 16 here. So this is just a very simple program that we have written inside the editor window. In this lecture, we wrote a very simple program using the editor window. We saved the program and also ran the program. Thank you so much for your time. Bye for now. Hello and welcome to this lecture. In this lecture, we'll be looking at what a Boolean data type is. A Boolean data type can only have two values. Either it is true or it is false. Let's have a look at some examples. We're going to do some basic math using some arithmetic operators just to determine some values. The first I'm going to do is a true. So let's say 4 is greater than 2. If I hit enter on my keyboard, it should return to true. I do another one, say 7 is greater than 9. That should return false. Okay, so this is how you use a Boolean. So the values in a Boolean is either true or it is false. There are no other values, true or false. So anywhere you see a Python code with the output true or false, you know you are looking at a Boolean data type. Try and practice with a few examples so you can get familiar with the Boolean data type. Thank you so much for watching. Bye for now. Hello and welcome to this video. What is a class? In programming, a class basically is a template that is used to create objects. A class is something that contains structure. So it defines how something should be laid out or structured. However, it doesn't actually fill in the content. For example, I could have a class called a car, and I could say the car needs to have doors, it needs to have wheels, it needs to have seats. But I won't specify what the class won't specify what the name of the car would be, or what type of seats or wheels it should have. Classes provide a means of bundling data and functionality together. So when you create a new class, it creates a new type of object, allowing new instances of that type to be made. So an instance is a specific copy of the class. So an instance of a class will have the templates for that class. Let's say I have a class called cars, and I want the cars to have, I'm building the template, so I want the class cars to have certain properties. So I want the car to have an engine, doors, tires, windows and lights. I also want the car to be able to perform some actions. So these are referred to as methods. For example, we want the car to be able to drive, to start, to stop and to park. So here we have laid out the template for the class called car. So if we wanted to create an instance of this class, an instance basically is a specific copy of the class that contains all the specified template content. So for example, I create a new instance of this car and another car and another car. So these are all instances of the car and they are known as objects. So these are all objects. In object-oriented programming, everything is known as an object. So these cars are all referred to as object, and they are also instances of the class car. You can create a class for anything. For example, you can create a class called animals, and you can specify a template for what those animals should look like. You can create a class called plants, called motorcycles, anything. As long as you specify the template, what members of that class should contain, then you can create instances of that class object. Even though the instances of the objects have the content or assume the template of the car class, they can also have their own property. For example, this car here, this object called Nissan, has a property called yellow. So it has a yellow color as a property that is specific to the instance of this class. So the key thing to know that an instance is a specific copy of the class. So it contains all the content of the class. For example, it has an engine, it has doors, it has tires, it has windows. It can drive, it can start, it can stop, and it can park. So the key differences between a class and an instance is that the class is the actual template, while the instance is a specific copy of that template. Thanks for watching. Bye for now. Hello and welcome to this video. In this video, I'm going to do my best to explain what the self variable is. This variable tends to trip a lot of beginners up, so I just want to do my best to explain it the best way I can. The self variable basically is a reference to the current instance of the class or the object. So I'm going to illustrate by creating a very basic class. A class is basically a template for creating an object. So here is a basic class I have created. So I've created a class called restaurant, and then I've assigned it a property called bankrupt, which is currently set to false. Next, on line 3, I have a function. So I've assigned the class a function called open underscore branch, which what that means is that this function open underscore branch will only happen if the value of the bankrupt is false, which means that the restaurant has money, so it's not bankrupt because the value is false. So now that we've created a class called restaurant, let's make an instance of that class. So I've created an instance of the class restaurant and I've called it X. So now X is a restaurant which has a property bankrupt and a function called open underscore branch, and we can access the property of the class by just typing in the name of the class, this class name here, the instance dot bankrupt. That will give us access to the property. The above command on line 8 can also be represented like this. So this x.bankrupt can also be represented as restaurant.bankrupt. So now you can see that this self here in line 3, the self refers to the bound variable or object. In the first case, it was X because we had assigned the restaurant class to X, whereas in the second case, it was referred to as restaurant. Now we have another restaurant called Y. So now we have the second restaurant called Y. By declaring the second instance of that restaurant, the self variable will know how to access the bankrupt value of Y and not X. So you can see here the bankrupt value of restaurant Y is true, while the bankrupt value of restaurant X is false. So this self here will reference the specific instance of that property. So the first argument of every class method, this also includes the init, is always a reference to the current instance of the class. So by convention, this argument is always called or named self. If you're using it with the init method, self refers to the newly created object. In other class method, it refers to the instance whose method was called. We can re-represent this code here in a different format. So we represented it again here. This keyword also represents a reference to the current instance of the method or object. So you could use this, or you could use the self. So anyway you see that, it means they are referring to the current instance of the class or the object. So that's it for this lecture on the self variable. I hope the explanation has made sense. Thanks for watching. Bye for now. Hello and welcome to this lecture. What is Tkinter? Tkinter is a Python module or package used to create GUI applications. GUI stands for Graphical User Interface. It is a cross-platform GUI toolkit. That means it will work on Windows, Mac, Unix operating systems. It usually comes bundled with the installation of Python. So if you've already got Python installed, you should have Tkinter. Tkinter provides a GUI interface for the TCL or TK, which are available, or which is available on most operating systems. So it provides an interface to the TK GUI toolkit, which is available in most operating systems, which includes Unix, Windows, and Mac. The TK itself is not part of Python. It is maintained by Active State. You can check from the command line to see if Tkinter has been installed properly. So let's test that. So open your command line. I've got mine opened, and just type in Python space hyphen m lowercase m space Tkinter, and then press enter. What should happen if Tkinter has been installed properly? It should bring up a window that will demonstrate or show a simple TK interface. So let's do that. Press enter. There you go. So this is a proof that Tkinter has been installed properly. This is the little symbol here for Tkinter. So you can drag that. There you go. So that shows that you have got Tkinter installed properly, because Tkinter comes bundled with the installation of Python. So excellent. We have proof that Tkinter is installed properly. Let's click on the quit and it should disappear. Most of the time, all you need is just the Tkinter module. However, the Tkinter module also has other additional modules that can come in useful. So just a quick summary, Tkinter is used to create graphical user interface, also known as GUI applications, and it basically acts as a Python interface to the TCL and TK GUI toolkit. That's it for this lecture on Tkinter. What you can take away from this is just know that the way you create graphical user applications with Python is by using the Tkinter module. Thanks for watching. Bye for now. Hello and welcome. In this lecture, we are going to briefly explore the TK and Tcl. TK is an open source tool used for GUI interface development. GUI stands for Graphical User Interface. So TK is an open source toolkit used for GUI development or GUI interface development. GUI stands for Graphical User Interface. Open source means it is free to use. TK provides a library of interactive widgets. These widgets are also known as GUI elements, which commonly are used in desktop applications. Okay, and they include things like menus, buttons, windows, text input field, and so on. TK was developed way back in the early 90s as an extension for a scripting language called Tool Command Language, which has been abbreviated to TCL and commonly pronounced as Tcl. So it was developed as an extension to Tcl, or Tool Command Language. It is also designed to be platform independent. That means it can be run on most versions of Windows, Mac OS, Unix, or Linux. So in effect, if you develop your application, your GUI application using TK, it will be able to run on most common operating system, as it is platform independent. Let's have an illustration of how the Tcl process works. So you have a Tkinter as a standard Python application interface. Okay, so this is the standard Python interface and is used to access the TK framework. So what happens when your Python program makes a call to the Tkinter? So your Python application makes a call to Tkinter. It then accesses the Tkinter Python modules, all right, which will include functions in the Tkinter package. This package is written in Python. So these functions, what they'll do, they will now pass the commands from your Python program and format them so that they look like commands from a TK script. They are then passed to the TK, they then pass to the underscore Tkinter extension module, which is written and compiled by C, or in the C programming language, and is able to make calls into the widgets in the TK library, which is implemented using a combination of C and Tcl, which is the tool command language, which is a scripting language. And then at the bottom end of the chain, the TK widgets then utilizes the xlib library to draw, which is used to draw graphics. Okay, it will use that to draw graphics. And so let's run through this illustration again. So you get the Python program makes a call to the Tkinter module, okay, which can be used to access the functions in the Tkinter package, which is written, this package here, which is written in Python. So these functions, okay, then pass the commands from your application, okay, and format them to look like commands from the TK script. That's what it does, okay? And then they are passed to the Tkinter extension, this module, and the Tkinter extension module. This module is written and compiled in the C programming language. What happens then is that it is able, this module here is able to make calls into the widgets in the TK library, which is implemented by using a combination. Okay, it makes a call to the TK widgets, which is implemented by using a combination of the C and Tcl. Using a combination of C and Tcl, which is the tool command language, using a combination of that. And here, and then you've got the Tcl, which is using the C programming language. Once that is done, the TK widget utilizes this library here, the xlib, which is used to actually draw graphics on the screen. All right. The TK version 8.0, with that, it introduces new GUI elements, which are themed to match the appearance of the standard elements in your operating system. So for example, if I run the Python Tkinter script to create, for example, a login screen in Windows, it will take on the native Windows appearance. Whereas if I run it in a Mac OS, it will change its appearance to reflect the Mac theme. This is useful because it allows you to write a cross-platform GUI application, which will maintain the look and feel of the operating system on which it's currently running. So that's it for this lecture on the TK and Tcl. Thanks for watching. Bye for now. Hello and welcome. In this lecture, I will guide you how you can install Python 3 and Tcl TK for Mac. Most installation of Python on a Mac are version 2x, so you rarely find a version 3 pre-installed. It's usually version 2.7 or so on a Mac. So I'll guide you how you can install version 3x, and also the latest versions of the Tkinter for Mac. This is important so that you can utilize the Tkinter module. So go to the Python download page. So you just type in Python download in your web browser, or you could go to the link there. So you type in python.org/downloads. So once you've got the download page, you just scroll down to the bottom here, where it's got the various, and just click on the one under downloads, click on Mac OS X. Click on that and you scroll down. It says the latest releases for version 3 is 3.52. So click on this here. And this is the Python 3.2 release. So you scroll down through the downloads and have a look. And the one you should be clicking on is this one here that says for Mac OS X 10.6 and later. So you click on that to begin the download. Once the download is completed, so you navigate to your download folder in the Mac and double click on the disk image to begin the installation. So by double clicking on that from your download folder, that should mount the image. I haven't got a Mac at the moment, so I'm trying as much as possible to give you as much information as possible. So once you've navigated to your downloads folder and double clicked on the disk image, what that does is should mount the image, and when it opens you can do a control-click on the .mpkg file. Once you do that, it will give you a menu where you can choose to open the file. Okay, so by selecting open, what that will do, it will bring up the Python installer. So click to continue to progress through the menus. Eventually what should happen, it should prompt you to agree to the software license agreement. Click the agree button and you should see an installation button. When you click on the installation button, it will prompt you for your administrative password. Enter the password and then click the install software button. After the installer finishes, you should have Python 3.4 on your machine. Once that's done, you need to download the Tkinter. To download and install the latest version of Tkinter for Mac, you need to go to this link here that I have got displayed on the screen, and that will take you to the download site. So this is the download site for the Tkinter for Mac OS. So just scroll down and look for your version. So for the latest version, you can click on that, the recommended Tkinter. Click on that, and that will take you to the active state website. So just click on that. And this is the active state website that manages the Tkinter. So scroll down to the page and look for the download that matches your operating system. So select your relevant one. So select this one, Mac disk image. So once the download is completed, you navigate to your download folder and then double click on the image file to mount it. So do a control-click to select the PKG file and choose open from the menu. This brings up the installer for active states, active TKL, 8 whatever version is displayed, which is kind of like similar to the Python installation. So click continue and then navigate the menu. You need to agree, select agree when you are prompted to agree to the software license agreement. And when you see the install button, click on that. And again, you may be prompted to enter your username and password. Enter your credentials and then hit the install button. After the active Tcore installation is completed, you can eject the disk image once you finish, and you can go to your Finder on your Mac, eject the Python 3.5, and also eject the active Tcore. So, all right. To test your installation has been successful, if you open up your Python idle and just type in import Tkinter, make sure the Tkinter is all in lowercase. If you hit return and if you get something like this, if no error messages, that means you have installed Tkinter correctly with Python upgrade 3.52. So that's it. If you get no errors, that means you have successfully installed the Python and the Tkinter. Thanks for watching. Bye for now. Hello and welcome. In this lecture, we are going to create our first Python GUI app using Tkinter. Let's open up our Python idle. We'll go to Start, All Program, click on the Python folder and click on idle. So this is the shell. So we open up a new file, new file, and we'll save this file as, save it on the desktop. I'll save it as Hello World. All right, so it'll be a basic application that displays Hello World on the screen. Before you can use any Python module, you have to import it. So here we'll type in from Tkinter import. By using the asterisk, what that means is that it will import all the functions and variables from the Tkinter package. Also notice the Tkinter is in lower case. In earlier versions of Python, like Python 2.x, is usually in uppercase. Next, we are going to use a tk constructor method to create a new top level widget. Okay, so this will be the main window, and we're going to give it a variable named root. So let's do that. So type in root equals to tk. So this is a constructor method. So this tk constructor method has been assigned to this variable called root, and what that will do, it will create a new top level widget, which will be the main window for the application. The next thing we'll need to do, we need to create a label that we'll use to display the text Hello World. So to create the label, we'll type in label. So the text we'll type will become a child of the root. So we'll type in root, comma, text, equals to hello world. Okay, and then a comma. No, I'll leave that. I don't want to add any more text. But we need to attach a method called pack. So it'll be .pack. What this will do, this is a method that will display the text in the window. Without this pack, nothing gets displayed in the window. So this .pack method is what will display the text or content in the window or GUI. So we've created a label, okay, with the text hello world, which is a child of the root window. And we've also used the .pack geometry management method. So the .pack is a geometry management method. We've used that to place the text in the window of the GUI. The last thing we're going to do is we're going to create a main loop for the application. So what this will do, we want it to be a continuous loop that will keep running to keep the window active. So the only way we can exit it is by exiting the application. So without creating this kind of infinite loop, the application will probably just close. So to create the loop, we'll type in root dot main loop. And what this will do, it will keep the window active for the application. So without this, once the text is displayed, the window might close. So we want the window to be active, so the application will keep looping through and running to keep the window active. So let's save the code and we can run the module and see if everything works out. So go run and click on run module. And that's the window there. I just drag it along. Okay, there you go. So that is the hello world. So without the .pack, this text will not be displayed. All right. So we have successfully created our first Python GUI application using Tkinter. That's it for this lecture. Thank you for watching. Bye for now. Hello and welcome to this video. This is going to be a two-part video where we are going to create a digital clock using Python from scratch. The first thing you need to do is open up the Python shell, and you can access the shell via the Python folder. So if you go to your programs menu and inside the Python folder, just click on this, that is a Python idle, and that will open up the shell. Once you've got the shell open, we need to open up a new file. So you click file and click new file. So this new file here is where we will actually write the program, and any errors that occur will be displayed in the shell. We are going to use a few Python libraries, so we need to import them before we use them. The first library we're going to import is the Tkinter library. So we need to import that by typing in from in lowercase space and then the word Tkinter space import and then asterisk, and this will import the Tkinter library, so it's available for us to use. So it's the first line you have to put in if you are going to use the Tkinter in your program. Tkinter is a library that is used to build user interfaces or interfaces in general. So we're going to import a sub library also from Tkinter. So we say from Tkinter. This one is going to be called TTK. Next, we're going to import the font. We want to use a font. Tkinter also has fonts you can use. So we'll do Tkinter import font. Next, we are going to import the time module because we need to use that. So import time. Next thing I'm going to do is import a module for date time. We're going to make reference to that. So that's it. We've got all our libraries. Next, I want to create a function. So def is what you use to define a function. And I'm going to call this function quit. So we'll use this to quit the application. And I'm going to pass in the arguments args and colon. Next, we'll type in root dot destroy. Inside the function we've just defined, we've got an asterisk followed by the word args. Basically what that is used for is used inside function definitions, and it's used to pass a non-keyworded variable length. So it will allow you to pass non-keyworded variable length arguments as a list, kind of like an array. So it allows you to pass several arguments provided they are not keywords. Keywords sometimes are reserved for the program, so you can't actually use them. Next, we've got the root.destroy method. What this will do, it will cause the main loop to exit. So when you, at the end of the day, when you close the window for the application, that's the method that will trigger the application to close. It will just close the session. The next thing we're going to do is create another function. This will be for our clock. So we're going to say df. I'm going to call it clock underscore time. You can call it whatever you want. It doesn't really matter. So I'm just calling it clock. All right. And you put a colon after that. Next thing I want to do is define a variable. So I'm going to call the variable time, and I am going to set this variable to equals to the date time. Don't forget we imported the date time, so we can use it now. So I'll do date time dot now, which will give us to the current time. The date.time method returns the current time also in milliseconds. So I want to avoid that. So to do that, I'll need to format the time using a special format function. So to do that, I've got to reference the time variable again, and I'm going to have to set that to equals to, and I'll wrap it round the variable dot. This is a special function here. It's called strf time. This is used to, it's a function used to format the time based on the arguments you've passed in. So I'm going to enclose that in double quotes, and I'll pass in the format I want. So I want the hour, a colon, and I want the minute, I put colon, and I want the seconds, and I close the double quotes, close the parentheses, and close the other parentheses. parentheses. Next thing I want to do is find a way to display our time. So we're going to do text, we'll say txt, which is text. We're going to set that to equals to the time variable. So there is a function or method called set.text.time, which text.set. So this is a method, and we're passing in this time variable here as the value. Next, we want to trigger the clock so that it starts after every 1 millisecond. So we do root dot after, and inside parentheses we pass in the milliseconds, a comma, and then we pass in the function, which is the clock underscore time. So that's it. So we'll end this video here, and in part 2 we will continue. So thanks for watching, and bye for now. Hello and welcome to the part 2 of creating a digital clock using Python. In this part we are going to build the user interface. So we start by typing in root, and we set that to equals to tk. The tk basically creates the root. Everything that you put on your screen, whether it is a text box, a button, or an image, is known as a widget, and they must all be placed in the root. So the root is kind of like a basket that you put all your widgets in. So let's add some more to this root. Next thing I want to do is set the attribute. So I'll do root dot attributes, and inside parentheses I'm going to specify the attributes. So I'm going to set the value for full screen. If you want your application to display in full screen, then you set the value to true. When it's full screen, it's hard to resize it. So I'm going to set that to false. But if you want yours to be full screen where it can't be resized, then you can set it to true. I would, just play around with it and see, but set it to false because it will make it easier for you to resize it to your taste. I want to set the background color for the clock. I want to set it to black. So you do root.configure, and then in parentheses you type in the word background, and you set it to whatever color you want. I'm going to set it to black, so I type in black. Make sure you always match up your quotes. Next thing I want to do, I need you to be able to click on the X button. You can see this X here. I want to create one for the application so that you can exit when you click that. So I'll do root.bind. So I'm going to bind this function here called quit. So I'll wrap that in parentheses. So I'll attach a label called X, and that X I'm going to also pass in the function called quit. So this root.bind will take in two arguments, this value X and then quit. This is the function I'd already defined. I'm going to trigger the clock again to start. To do root dot after every milliseconds I want the clock to start, so we'll call the clock underscore function, which is clock underscore time, and that will trigger the clock to start. I'd call this variable this here, and I'm setting that to a string variable function. In order to save time, I have completed the code. So let me just go through what I have added on. So here I've created a variable called fnt and set that to equals to font.font. So basically I'm using I specify the font family here called Helvetica, and I've set that the size of the font to be 120. The weight, that means I want it to be bold. And here I have defined this text txt variable, and I've set that to equals to a string var. What this means is that this will hold a string value by default. Okay. And here I am using this LBL. It's a label variable, and I'm referencing this TTK, which is a submodule of Tkinter. So here is where we are setting the properties for the clock. So we're setting the background, which is the foreground color of the clock, is going to be white, while the background of the actual clock, the text, is going to be black. This is different from this. This relates to the screen. This we're just setting this properties here. These settings are for the actual window, while these ones here are for the actual clock itself, the text that the clock displays. That's what these settings are for. That's the foreground color, and that's the background color, and this here is used to anchor it to the center. Here I've used the relx and the rely. Basically these are geometric functions in Tkinter. You basically use them to give a position that is relative to the window, while the anchor here is used to actually center the widget. Finally, on this line here, we've got the root.main loop. This basically handles the Tkinter event loop. So basically it keeps the application or the clock running until the window is closed. So that is it. So the clock is basically built. What I would advise you to do is make sure you format. There's options here to format. You can indent. Make sure your indentation is like mine, because this editor is very fussy. So if you don't indent things properly, it will complain. So make sure your indentation is spot on. If you get any errors, usually the errors will be on this side in the shell. Just response to it. Okay, so I'm just going to click save. Now I want to run the clock, so you can run it by just going run and click run module, and that will open up the clock. So hopefully everything should be okay. So this is it. So if you had this set to full screen, then it will take over your entire screen. But doing it this way, you can resize it to whatever size you want, and it's a more flexible approach. Okay. If you want, there's different formats. If you want to add the actual date to this, I have also created a line of code, but I commented it out. So let me just close this line of code here. I've commented it out, this one here. So this allows you, you can see the format here. This will display both the date and the time. So what I'm going to do, I'm going to comment this out. If you want to comment something in Python, you do that using the hash symbol. It's very useful. It enables you to try things out. All right, so I'm going to use a different format here for the time. So it's going to give me both the date and the time. So I'm going to click save and I'll run this so you can see the difference. And this should hopefully show. Let me just expand that so you can see. It's quite big. Okay, I probably need to reduce. So you can see it shows both. Because I've got it so big, that's why it's covered the screen. All right, what I need to do, let me just reduce. I'll close that. Come here where I've got the size of the font. I'll just reduce that to 60 because the screen has more to contain. And I'll run that again. The screen should be smaller now and it should be able to see everything. So you can see that. So if you prefer this format of the clock, that's fine. Then what you need to do is use this code here. Okay. If you don't want that, you don't need this. I'll just get rid of that. This is just, I don't need that anymore. This was just a comment. Okay, so I just tab up. All right, so if you decide you only want to show the time, you don't want the date, then you comment this line out and use this line instead. I prefer just the time at the moment, so I'm going to comment this out. I don't want the date, but it's good to have the option so that you can choose which format you like. So I'll go back to the format I chose. Since I've got less text to display, I'm going to increase the font size to 120 so that it appears big on the screen. I'll save that, run that again, run the module, and that is it. Yep, I prefer this format. Okay, make sure you save your work, always save it. So when you save, you go to click save as. And I've saved mine as digitalclock.py. py is the Python extension. Okay, save any way you like. I've saved mine on the desktop. Okay, so that's it. That's the end of this project for the digital clock. I hope it's been useful. If you do have any problems, please feel free to contact me. Thanks for watching. Bye for now. Hello and welcome to this video. In this video, I'll be showing you how to run your Python application. When you create a Python app, you usually have to save it with a .py extension. So for example, this is a Python app. You can see it's got a .py extension. So if you wanted to run this program, all you had to do is double click on it. That's one way. So when you double click, it gives you two windows. You need to have two windows because one of them will start the application, which is the py.exe, and this window is the actual application. So what you need to do is minimize the one that says py.exe. This one here that says py.exe, that's the one you need to minimize, and then this will become the application. Okay, so this will be the actual application while you've got the .exe running in the background. This is what powers the application, so you must have it in the background. Just minimize it. So that's one way. The other way, you can run it through the Python idle. So you go to Start, All Programs, and look for your Python folder. Inside there, you've got the Python idle. Click on that. And this is the Python idle. So while you're in the idle, you can open this, any Python file that's got a .exe extension with a py. So I can browse to this from the idle by going open. So by browsing to this, I have now opened it in another window. So this is the actual code that runs the application. So to run it, you can have the Python shell open, so if there's any errors, any issues, it will show in the editor, in the Python shell. So you can just click run and click on run module. Okay, so while the module is running, you can minimize your shell and just let the application run. All right, so those are the two main ways you can run your Python application. Thanks for watching. Bye for now. Hello and welcome to this video. This is going to be a 3-part video series where we're going to create a countdown timer using Python. Countdown timers are very useful. You can use that to count down to several events, for example, holidays and other related events that are of interest to you. To begin our development, you need to open up the Python shell, and you can access it via your programs menu. Inside the Python folder, there is the idle. Just double click on the idle and that will open up this shell. So once you've got the shell open, we need to open up a new window. So you go File, New File, and inside this area here is where we'll develop our application. So the first thing you need to do is save the file. So you do File, Save As, and you can save it anywhere you like, but just save it with a .py extension. Actually, you don't need to, because it's already done that for you here. All you need to do is give it a name. So I'm going to call mine Countdown, and I'll just save it, and I'll save it on my desktop. Okay, that's it. So I've got the file. So this now is a Python file. I want to use some Python libraries, so before I use them, I need to import them. I'm going to import Tkinter, which is a module that is used to create user interfaces of various types. So to import that, I just need to type in from space Tkinter I can't spell today. Tkinter, that's it. From Tkinter, then you type in the word import space asterisk. So with the asterisk, it will import the library. Next, we want to import another library. It's also a subset of Tkinter. So do Tkinter space import space, this one's called TTK. Next, we want to import a Tkinter font, so we can use a font from Tkinter. You type in the word import followed by what you're importing. So we're importing the font element. Next, I want to import the time module. So I just type in import time. Also want to import the date time. So I type in import date time. All right, so I've got all my libraries and class methods ready. First thing I want to do is create a variable. It's going to be a global variable. A global variable means it will be available throughout the application. Python variables are scope based, so you can have a variable that is local or exists only within the module. But by declaring it global, that means I want it available throughout the application. So I just type in the word global followed by the name I want to call it. I'm going to call it end time. So we'll use that later in the application. So I want to create our first function here, And to create a function, you type in def followed by the name. I'm going to call this count underscore weight. That's going to be the name of my function. Actually, before I create that function, I want to create another one first. I want to create a function called quit. This will allow us to quit the application, and inside the parentheses I'm going to pass it arguments. Okay, and that's it, and semicolon. You use the asterisk and the args, which stands for argument. So what you normally do when you're not sure how many arguments might be passed to your function, you use the asterisk and X. What that does, it allows you to pass an arbitrary number of arguments to your function. And inside this quit function, I'm going to add a root method. So I'm going to say root dot destroy. And what the root dot destroy does, it will cause the main loop of the application to exit. So when the application keeps running and this function or this method is called, it will exit the application from the loop. One more thing I want to do before we wrap up this video lecture, I want to create another function. This time I'll call it count underscore weight, but feel free to call yours whatever you like, and then the parentheses and the colon. And I'm going to create a variable, and I'm going to call this variable time left, and I'm going to set that to equals to the end time variable, which is this variable here, the global one. So I'm setting it to equals to that minus the date time dot datetime dot now. This is a method, a time function. We've imported the datetime and the time module, hence we're able to utilize it here, and this will give us the current time. So if we take away the value of this end time from this method here, it will give us the time left over for our event. I have added some more line of code so as to save time. So I've added this line here. What this does, it takes away the microseconds. Okay, so if without that, the time will display after the seconds, it will also show some microseconds. So I'm using this value here to take away the microseconds so that we don't have that displayed. And then here I've created, this is what will display the clock. Okay, this will show the time that is left to your particular event. This is what we've used to set that time. And this here, this piece of code here, is used to trigger the countdown after 1000 milliseconds. So I'm going to end this lecture here, and we'll continue in part 2, where we will start to build the interface for the countdown clock. So make sure you save your work. Just click File, Save, and we'll see you in part 2. Thanks for watching. Bye for now. Hello and welcome to the part 2 of creating a countdown timer with Python. Before I carry on, I just want to elaborate on some key differences between the Tkinter, this one, and the Tkinter import for the TTK. All right. The difference is a lot with the widgets. With the widgets in Tkinter, they are highly and easily configurable. So you have almost complete control over how they look, their border width, the font, the images, the color, and so on. The widgets that are controlled by TTK, they use styles to define how they look. So it takes a bit more work. If you want a non-standard button, then TTK widgets are also a little bit more, they are more difficult to configure. So they're both run under different types of engines. So generally speaking, the theme widgets that makes your application look more elaborate and more elegant, you get that with TTK. But the TTK are less configurable in comparison to Tkinter. All right, let's carry on. So we're going to create, say root is equals to TK. The TK method or function, what that does, it creates a root. So everything that you put on the screen, whether it is a text box, a button, or an image, is referred to as a widget, and they must all be placed in the root. So you can think of a widget like think of the root as a basket that you put all your widgets in. So now that we've got the root sorted, let's try and add some properties. So we are going to say root dot attributes. I'm going to set the attributes, and this is relating to the screen. So we're going to set how we want the screen to be. So you do double quote dash full screen. If you want your application to be full screen, then the value, you have to set the value to true. I want to be able to control how the screen looks, so I can resize it. So I'm setting that value to false. So I want to set up the background color for the main screen. So you do root, which is the main window. So the root dot configure, and inside parentheses you type in the word background. I'm going to set the color to black. And close the parentheses. The next thing I want to do, I want a button like this X button to be on the application, and I'm going to bind that to this function here called quit. So when you click on that X, it will quit the application. So I do root dot bind, and inside the parentheses for that method, I am going to do a double quote and then the X. So this will be the X on the screen that you can click on, and the other argument I'm going to pass in is the function called quit. Okay, so I'm passing that into there as well. Next thing I want to do is call the function, this want to trigger the clock. So we do root to call the timer again. So we want the timer to start again here after 1000 milliseconds, and we're passing the can't wait function. Okay, so we specified it here. We're doing that again here. So this is called here once the screen is activated. So that's it for this video. We will conclude in part 3. In part 3, we are going to actually set the end date and the time for the countdown. So we're going to set when we want the countdown to begin. So we'll do that in part 3. Thanks for watching. Hello and welcome to part 3 of creating a countdown timer with Python. So we are now going to set the end date when we want our event to end. So we're now going to set up the end date so we can start counting the time. So we created a global variable here called end time. So I'm going to use that now. So I'll say end time. I'm going to set that to equals to the date time dot the date time method, and inside that method, in between the parentheses for this method is where I will specify when I want my event to end. So you start with the year 2017, followed by the month. Here's the 9th month, followed by when I want it to end. I want it to end at the end of this month, so I'll say 30th. Okay, and then you pass in 0 just to format it, and 0. So if you have a month that doesn't end in 31, that has 30, for example, if you put 31 and you know that September only has 30 days, it will throw up an error. So this here, the first 0 will represent the hours, and the second 0 will represent the minutes. So now we've set a value for our end time variable here, which is going to equals to be the date time, and inside this date time module we have a method called datetime, and we're passing it a value of the year, the month, the day, and then the time. This first 0 will represent the hours and the seconds, and the other one represents the first 0 represent the hours and the minutes, and the other 0 represent the seconds. We imported the font from Tkinter, so let's try and use that as well. So to use that, we are going to create a variable. So here I'm going to create a variable called fnt, which is short for font. You could call it anything, doesn't really matter. We're going to set that to font and then inside the parentheses of this font method, we are going to pass in several properties. First, we want to pass in a font family, and we're going to pass in a font called Helvetica. Okay, and next thing we want to do, we want to give the font a size. So I'm going to set this to what shall I give it? I'm going to make this 90, and I want it to be bold, so I'll say weight equals bold. Weight means how thick you want it to be, so I just set it to bold. Oops, I've got my quote outside of the parentheses. It should be inside. To save time, I have completed the rest of the code here. So we've already covered this one. This is where I set a new variable for the font and passed in these values here. This will be responsible for the size of the clock of the tick. Okay, that will control the size of the text on the screen. Here I've defined a variable called text. When you define variable, you can always change the values. So this variable here, I've set it to equals to string var. What that means is that this will accept string values. So the values that will be passed into this variable is going to be string. And here we've got a label, and here I'm using the TTK module, this one here, and the label I'm using here for the label, which is the root, that is the root of the application. I'm setting a text variable to equals to text. I'm setting the font to equals to this font here, the variable. The foreground color, which would be the color, not the background color, the color at the front will be white, the background will be black, and here, this here is used to position the clock on the screen. This anchor here positions it in the center, and this two here, real X and real Y, are used to position the X and the Y axis. And then here we've got the root.main loop. So this keeps the application running. So this is what keeps the clock running until you exit it. So it handles the event loop. Okay, so each time the event loops, it handles it, and it keeps the application running until the window is closed. And when the window is closed, it usually calls the quit function here and then exits the application. So that should be it. So I'm just going to save this. Make sure that you format your code just like I have. If not, this editor here will complain. It's very fussy. It likes its code to be formatted in a certain way. So if he complains, just respond by formatting the code properly. So this is it. So I'm just going to test to run the application. So I'm going to click run module. Okay, that is it. So it tells me I have 22 days left. 22 days, 7 hours, 58 minutes and 53 seconds left to my event. So you can always change the value of when you want your event to end. So that's it, how you create a countdown timer in Python. Thanks for watching, and bye for now. Hello and welcome to this video. This video is going to be the part 1 of a series of videos on creating a calculator with Python. The first thing you need to do is open up the Python shell. So the way you access it is via the Python folder. So if you go into your programs file, there's a Python folder, and just click on the idle, and that will launch the shell. So once you've got the shell open, we need to open up a new file. So click on File, New File, and this file here is where we will write the code that will build the calculator. The first thing I'll recommend you do is save this file. Save it as a Python file. So you do save as, and then give it whatever name you want. It's already got the Python file format here, so you don't need to worry about that. Just give it a name. I'm going to call mine calculator. And I just press save, and that will save it. I want it to save on my desktop, so I click save. So this file now is a Python file. The first thing I want to do is import a library. The library I want to import is called Tkinter. It's a library used to generate or create graphical user interface. So to do that, we need to import it. So you type in from, then you specify the name of the module. So this is a module, it's called Tkinter, space, and type in the word import, space, asterisk, and that will import the library into the application for me to use. The next thing I want to do is create a class. A class basically is a template for creating objects. So I type in class, followed by the name I want to give the class. So I'll call it application. And when you create a class, you can also pass in arguments or parameters into it. And I'm going to pass in a frame as an argument into that class. And when you create a class, you also have to put a colon there. So this will be the main class for the calculator. Notice I've passed in frame there. A frame basically is used to group and organize other widgets. So it's kind of like a container object for all the widgets the application is going to use. So inside this class, I'm going to create a function or a method. So to define a function, you type in the word def followed by the name. So I'm going to use the init. So you do underscore init underscore, and then in parentheses is where I'll pass in any arguments I want inside that function. This underscore init underscore function is a special function that is called when an instance of a class is created. So you use that to initialize that instance. So inside the parentheses, I'm going to pass in two arguments. I'm going to pass in a self variable and master. The self is a reference to the current instance of the class. Okay, that's what that self is. And then the master represents the parent widget. So now let's initialize the frame. So to initialize the frame, we're going to use a special built-in function. And the built-in function is called super. So inside the parentheses, I'll pass in some values. The super function is a built-in function which returns a proxy object to delegate method calls. So it uses that to delegate method calls to a class which can either be a parent or a sibling in nature. So inside the super function, I passed in the application class here, and also a reference to the self variable, and here I'm using the underscore init again to initialize the master widget. This master also is known as the parent widget, so we're initializing it here. To save time, I've added a few lines of code here. So I've added these lines of code. So the self again is a variable that it's a reference to an instance of a class or an object that is created. So here I'm setting this to blank, and then here I'm using the self again dot user input. This is going to be a user input variable, and I've set that to equals to the string var. Basically, this string var is going to hold a string, and the default value is blank, but I've set this to make sure it holds a string value. Then here we've got the grid method. The grid method basically is used to register a widget with the grid geometry manager. So if you don't do this, the widget will exist internally, but it will not be visible on the screen. So the grid is used to register widgets with the geometry manager. The geometry manager is used to manage the placement and the layout of the elements of the GUI. The create_widget function, which we'll use to create widgets. So that's it for this part. Thanks for watching. Bye for now. Hello and welcome to part 2 of creating a calculator with Python. In this part, we are going to focus on creating all the buttons for the calculator. So we're going to create a function, and within that function we'll create the buttons for the calculator. So let's create a function that will be responsible for creating our buttons for the calculator. So to create a function, you do def space followed by the name. So I'm going to call it create. I'm going to use this here, create underscore widgets. So there will be widgets, and I am going to pass in self, the self variable, into that function. And inside this function is where we define the various buttons. The user input is going to be stored as an entry widget. So inside this function, this create function, we are going to make reference to the entry widget. To save time, I have added some line of code here to the function that I created. So here we've got a reference to the self variable .user underscore input, and we're setting this to equals to entry. This refers to the entry widget. The entry widget is basically used to accept single line text strings from a user. If you want to display multiple lines of text that can be edited, then you need to use a text widget instead. If you want to display one or more lines of text that cannot be modified by the user, then you should consider using a label widget. So here we're using an entry widget to accept a single line text strings of input from the user, and here we passing it. This is the background color. BG refers to background color, and this is a hex value I've given it. You don't have to use hex value, you can just type in the color you want. If it's brown, white, but enclose it in quotes. And here we're referring to the border. BD stands for border. So the default value is usually in pixels, so I'm setting the value here to 29. So this will be the size of the border, and the value is in pixels. And here we're inserting the width. We're setting the width to 4. So there's a difference between the insert width and the actual width. The insert width basically is the width of the insertion cursor. So it references the height. So its height is determined by the tallest item in its line. And the default value is usually 2 pixels. But I've set it to 4. And here the width basically refers to the width of the widget in characters, not pixel value. And it's usually measured according to the current font size. And here we've got a reference to the font. So the font I've specified to use is Verdana. When you specifying values, you need to enclose them in quotes if they are text or string values. And this 20 here refers to the size of the font. Bold means I want it to be bold. Here we've got a text variable here, which I'm setting to equals to the self variable.user input, and I'm using the justify here to justify its position to the right. And here we are using a grid method for the input, and this is the column span for the grid. And on the screen of the calculator, we are setting a default value of 0, so the calculator will have 0 on the screen as a default. So I have now added a value here. This is for the button. So I've started, this is the code for the button here. So this is going to be the number 7 button on the calculator. So this is the piece of code I've got for it. So here again, we're referring to it as button1.self. This will be the variable, and I'm setting that to equals to button. And inside this button method, we've got reference to the BG, which is a background color. I've given it this as a background color, and that is the border. I've set the border size to 12. Usually it will be in pixel values. Text, this is the text that will appear on the button. It will have number 7 on it. This PADX refers to external X padding. So this dimension is added to the left and the right outer or outside of the widget. So the dimension you apply to the left and the right outside of the widget. So that's what you use for the PADX. So this is the value I've given it. And next to it, we've got PADI. PADI basically is for external Y padding. Y, this refers to the padding on the X axis. This PADI Y refers to padding on the Y axis. So it's basically external padding, and the dimension is added to padding above and below the widget. And here we've got the font. I've set the value of the font to Helvetica, and the size is 20, and I've made it bold. Here we've got command. We set that to lambda. Lambda basically is an anonymous function. So it's a keyword used to describe an anonymous function. So here we've got a self button.click. We've not defined this method yet, but we are attaching it to this here. So later, once we create the button once we write the function for this button.click, when someone clicks on the number 7 button, it will fire off the logic inside this button.click method. And here we have got a grid with row of 2. The row number, basically this refers to the row number into which you want to insert the widget. So the counting starts from 0, and the default is the next higher numbered of unoccupied row. So it basically refers to where you want to insert the widget. And I've said I want to insert it after the second row. The column number basically refers to where you want the widget to be gridded, where you want the grid to apply. This column here, okay, I've set it to equals to 0, which is the default. I've also set the button here with a value of sticky. Sticky, basically this option determines how to distribute any extra space within the cell that is not taken up all by the widget. So any extra space that the widget doesn't occupy is sorted out using this sticky. So it will distribute the extra spaces. If you do not provide a sticky attribute, the default behavior is to center the widget in the cell. So I've given it a value of W. What that will do, it will stretch the widget both horizontally and vertically to fill the cell. So this button is the number 7. All the rest of the buttons are going to be identical. So what I'm going to do, I'm just going to copy this piece of code here and just change the relevant button number. So I've added the other buttons that the calculator would need. So this was the one we did together, number 7. So basically the code is the same. All I've done, I've just changed the text number. So this will now be button number 8. And this will be button number 9. This will be button number 4. This will be button number 5. This will be button number 6. So let me scroll down so you can see the other buttons. This is text button number 1. Say this is 2, 3, and 0. This will be the addition button. This will be the subtraction button. And this will be the multiplication button. And this is the division. The division is you do division with a slash. That's how you identify division in Python. So you use a slash. Most programming languages actually, you use the slash to indicate a division. And also I've got the equals to button. So when you do the calculations, you want an equals to button. So this is the equals to button here. And I've also got a clear button, which I'm going to have the text set as AC. So you can clear what's on the screen. So that is all our buttons that we're going to need for the calculator. So that's it for this lecture. Thanks for watching. Bye for now. Hello and welcome to the part 3 of creating a calculator with Python. Before we carry on from where we stop, I just want us to quickly look at the code we have so far. So we started off creating a class. Then we have a few functions here. We created a function called _init. We initialized the frame. So the master here basically is the main window of the application. We had created a class called widgets. And here we have the different buttons created as widgets. So most of the code within the buttons are the same. The equals to button, this is the equals to button here. Here we have where we've got the sticky, set the sticky to equals W. We've got the column span to 2. Normally when a widget occupies one cell in the grid, you can also grab multiple cells of a row and merge them into one larger cell by setting the column span option to equals to the number of cells. So we've used the column span here, and also here we've used a command. Notice we didn't use lambda there. Here we've used a command and we've set that to self.clear display. What this will do, when you click on the clear button, it will clear the display on the screen. So that's what that will do. Also here we used the self.task and we've set that to blank. Basically a task is a subclass of a future. A future basically is an object that is supposed to have a result in the future, and the task is a subclass of that future. So let's go ahead and create a few more methods of function. During the creation of the buttons, we attached it to the button.click method, which we haven't created. So I've now created it here, and the button.click method here. So it takes in the self variable and the number that the user inputs into the calculator. So here, this is the logic. So we're doing the task.self. We're setting that to str.self. This here is a special string class, str, and inside the parameters here, we've got inside the parentheses the self.task plus the str and then the number. Str is a special string function class. Okay, and here again we're using the we're using the self variable dot the user in, and we are setting that to this self dot task. So this is for the button click method. So when they click on the button, it will kick off this logic inside this code here. So take note that this str we have used is a Python built-in string class. It's a string class which is a built-in function, built-in class in Python. It's a built-in class called str. It's a string, built-in string class called str. I've created another function here called calculate task. Again, I passed in the self variable here, and this function I've also attached some error handling. Python allows you to implement errors and exceptions to be handled by your program. So it allows your programs to handle errors and exception. In order to do that, you need to use both the try and the except statement. So here is my try statement, and this is what I've specified, and here is the statement for my except. So this try and the except are there to handle any errors in the application. So basically what this is doing here, this function here, any data that is passed into that variable, it's going to be any input. So it's taking the input, is getting the input from the user and then passing it into this variable here, and it will catch any errors here using this try. So if the answer evaluates 2 equals to that, it will display. If there's any error, the error will be captured. Okay, so this here is used to display the text of the answer, and this also self.answer will display any task that's been inputted. And here it's a syntax that will capture any invalid syntax you enter or any error messages. It will be captured there. I've added 2 other functions here. This one here called display text, and passed it the self and then the value that the user inputs. So again, this is what it will do. You takes in the input from the user, and if you decide to delete your entry, these are the parameters it will take. And if you're inserting, this is a code that will handle the insert. Again, this is a function. This function is responsible for displaying the text. This function here is responsible for clearing the display. Okay, so any input you enter here, you can clear it using this piece of code there. So here in this bottom here, I've added this here. So we're setting the calculator to equals to this tk method, which we specified earlier on, the tk root. So we are here with this title. We're using that to set the title for the calculator, and this is what we'll call it. Okay, this tk here is a root, so it's telling that the root of the application will be the calculator, and app. The app here refers to the application name. This is the name of the application. It's called calculator. This here, you use that to make the window a fixed window, so the window cannot be resized. Okay, so hence I'm setting the height to false, so you cannot resize the window of the calculator because of this line of code here. And this is the main loop of the calculator. This is the event loop. This is what keeps the calculator running until you exit the calculator. So that should be it. So I'm just going to click save. So let's do a quick review of our code. Make sure the code is also formatted properly. If your code is not formatted properly and you try to run it, it can cause syntax errors and the editor will complain. So make sure you've got it structured the way I've structured mine. I've also added some comment here. So anything you see here in green here, these are all comments. When you run the application, the comments are ignored. Okay, so these are comments, and also this here is a comment. Anywhere you see the hash symbol is also a comment. Okay, so these are all comments. It just helps give you a description of what we've done here. So this tells you here that this is the main class for the calculator. It tells you here we are initializing the frame. Here we're creating all the buttons for the calculator. Here the user input, we're storing them as an entry widget. Here is the button for value number 7. In here we've got value number 8. So these are all comments. Anything you see a pound sign is a comment, and so on. So I've commented out, just put a comment before each line so you know what they do. Okay, so make sure your code is formatted this way. In here there is a format option to indent your code. So if you know it's not indented properly, make sure you do that so that the editor doesn't complain. So you notice within the functions, you see where the functions created, and then the other actions, the logic inside the function, there's indentation. You can see that. Even with the class, you can see the class, the indentation from the class, and the methods. If I scroll down, you can see the indentation also. Okay, you see how it's all indented. All the logic is indented underneath the respective methods. Okay, so make sure it's all sorted and structured in this way. So once you've done that, you just click and save. And let's try and run the application. So we click run and do run module. Hopefully, yep. Okay, that's good. So this is the application here. Let's see if we can do some calculation. So that's 8 times 8. That's 64. We'll clear that. 9 plus 9, 18. We'll clear that. 56 minus 8. We clear that. So all the, what one have we not used? Let's do a division. We do 82 divided by 6. Okay, clear that. 9 divided by 3. Clear that. So we've got all the buttons and the functionality working properly. So this concludes the series on creating a calculator with Python. Thank you for watching, and bye for now. Hello and welcome. We are going to be creating a weight conversion tool that will convert feet to meters. This is going to be a 3-part video project. So we'll start in part 1. It's always a good idea to try and design or sketch out what you want your application to look like before you actually go ahead and build it. So this is a rough sketch I've made. So the application is going to have a title, which is going to say feet to meters. It's going to have an input box where you enter the value in feet, and then you press the calculate button. It will display the equivalent in meters. So I will be using the Python idle for this project. So to access the idle, you click on your programs menu, wherever your Python folder is. You click on it and double click on the Python idle, and that will give you access to the shell. Once you've got the shell open, we need to open a new file. Click on new file. So this file here is where we will create our project. All the code we will write, we'll write it inside here. So the first thing to do is to save this file as a Python file. So you do save as. It already knows it's going to be a Python file, so we just need to give it a name. So I'm going to call it F2 meters. So feel free to call yours whatever you like, and then save it in whatever location you want. I'm going to click on desktop and save mine to the desktop. So anything I create here now will become a Python file. For this project, I want to use a couple of Python modules. So before you can use the modules in Python, you have to import them. So I'm going to import it using the word from space followed by the name of the module. It's called Tkinter, space followed by the word import, space, and then asterisk. And the second module I'm going to import is called Tkinter as well. So it's Tkinter space import space TTK. So these two lines basically tells Python that our program needs these two modules. The first module is called Tkinter. This is the standard binding to TK, which when loaded also causes the existing TK library on your system to be loaded. So if you got TKs on your system, it will cause it to be loaded. The second module, which is TTK, is Python's binding to the newer themed widgets that were added in TK version 8.5. So the difference between the two is that with the Tkinter, the first one, you can configure the widgets, almost as you like. Whereas the second one, the TTK, is more locked down, but it's more professional. Okay, so if you want a professional looking widget or theme and you don't want to configure it much, then TTK is your option. But if you want to have total control, then you use the widgets within the Tkinter module. Notice that we've imported everything from the Tkinter module, so that we can call the Tkinter functions and every other thing that relating to that module. So you can call them without prefixing them, okay, which is the standard Tkinter practice. However, because we've imported TTK itself, that means we'll need to prefix anything inside that TTK module. So if we're using like an entry module, really, we need to specify that. So if the entry widget is a TTK one, so you need to specify TTK dot entry. You need that in order to invoke the function inside the TTK module. Sometimes you need both modules, other times you need just the one, depending on the context. To save time, I've added some lines of code here. Okay, so I've added these lines of code. Here we've got the root equals to TK. Basically what we're doing here, we are setting up the main window for the application. And here the root.title, we're giving it a title. We're calling it feet to meters. So this will be the title for the application. And then created a frame widget. Okay, this is a frame widget which will hold all the content of our user interface. and also place. We'll place that inside the main window. We've defined the main window here, so this frame will be placed inside the main window. This bit here, the column configure, this bit here, what that does, it tells TK that if the main window is resized, the frame should expand to take up the extra space. Okay, that's what this line does. The row number, I've got row here. The row configure, basically what that will do, it will configure the row. So the row number basically is the row into which you want to insert your widget, and the default counting starts from 0. So the default is the next higher value for the unoccupied row. Notice we've got the sticky option here, this sticky here. Basically, that option determines how to distribute any extra space within the cell that is not taken up by the widget. If you do not provide a sticky attribute, the default behavior basically is to center the widget in the cell. You can position the widget in a corner of the cell by using the sticky word, and it has certain values. So these values refers to the way you can make the widget stick in the cell. NW refers to not from bottom to left. Okay, so if you're doing NW, is top left. NW refers to top left if you want it to be positioned top left. And then E refers to, E will be the right center, and then will stretch the widget in a vertical position. So that's what these values are. They are geometric values, and these values are all part of the grid method. So I'm going to end this lecture here, and we will carry on in part 2. So see you in part 2. Thanks for watching. Hello and welcome to part 2, where we will continue with the creation of the weight conversion tool. To carry on, I'm going to add some lines of code that I have already pre-staged. I have added some more lines of code here. So this is the line of code I've added. So here we've got a variable here. I've set it to a string var method. That means this will accept string values. Here again, the meters variable is set it to a string var, which means it will accept string variables. I've also created 3 main widgets for our program. We've got the entry, where we will type the number of feet, which is this here. This is where we'll type the number of feet. Okay, and then a label where we will put the resulting numbers of feet. Okay, this label here is where we will put the resulting number, and I've got a calculate button that we will press to perform the calculation, which is this line of code here. For each of the 3 widgets that we have created, we need to do 2 things. We need to create the widget itself, and then we need to place it on the screen. All the 3 widgets, which are children of our main content window, are created as instances of one of the TK's themed widget classes. The same time we create them, we also need to give them certain options, such as how wide the entry should be, the text, the position of the text inside the button, the entry and the label, we need to assign each of them text variables. So you can see the text variables here I've attached. When you create widgets, they don't automatically show up on the screen. This is because TK doesn't know how you want them to be placed in relative to other widgets. Okay, so this is where the grid method comes in. Remember when we did in here, when we were doing the frame, we did a bit of grid. There was some grid involved in there. So we place each widget in the appropriate column. So it could be column 1, 2, or 3, and also in the appropriate row. So for example, row 1, 2, or 3. We've also used this sticky option here. You can see the sticky. The sticky option says, or it's used to specify how the widget would line up within the grid cell. So it does that using the direction of the compass. So W stands for west, which means anchor the widget to the left side of the cell. WE stands for west east, which means anchor it to both the left and the right side, and so on. Next, we're going to add some lines of code that will create 3 static text label that we will use for the user interface. So I've now added the lines of code. These are the labels that we'll be using for the user interface. All the 3 lines of code here, they do exactly the same thing for the 3 static text labels that we are adding to the user interface. So each one is created and placed in the appropriate cell in the grid. So I've added some more line of code to finish up the user interface. So these are the lines of code I've just added on. So let me just walk you through that. The first line here, so I'm using a for loop here. So that first line there basically will walk through all the widgets that are children of our content frame, and it will then add a little bit of padding around each, so they aren't so that they are not all squashed up together. That's what that does. We could have added these options to each of the grid when we first put the widgets on the screen, but doing it this way is a nicer and a shorter way. That way we don't write too many code. This line of code here, that line basically tells TK to put the focus on our entry widget. So anyway, you see me talking about TK, I'm making a reference to the TK function, which is part of the Tkinter module. So this line here, like I said, is basically used to tell TK to put the focus on our entry widget. That way the cursor will start in that field. It's best to do it that way so the user doesn't have to click it before starting to type. And let's move on to the third line, which is this one here. The third line basically tells TK that if the user presses the return key, enter on a window, anywhere within the root window, that should call our calculate routine. Alright, so if the user should press the return key or enter, so return and enter is the same thing. So if they press, if you're on a window, it will be enter, on a Mac probably will be return. So if the user should press that, TK basically will respond by calling the calculate routine. Okay, the same will happen if the user presses the calculate button. And then we've got the main loop here. This event loop here, this is what keeps the application running until the application is closed. So the application will keep running and looping until it is closed, and it is controlled by this root.main loop. It is what controls the events that occur within the application. So that's it for this part. In the final part, in part 3, we are going to create the function that will actually perform the calculation. Thank you for watching, and see you in part 3. Hello and welcome to the part 3 and the concluding part to the video on this project for creating a weight conversion tool. In this part, we are going to create the function that will do the calculation. So we're going to define the function right at the top of the document here of the editor. Just underneath this module here is where I will define the function. So we call the function, you define the function by typing in the keyword def followed by the name. So I'm going to call it calculate, and inside the argument of the function I am going to pass it this value. You use this when you're not sure the number of arguments you're going to pass through. So this represents the arguments that will pass through that function. And when you create a function, after the parentheses you put a colon there, and then now we'll start to define the logic for the function. To save time, I have added the logic here. I'm just going to explain what the bunch of code I've added here means. So here I've defined a calculate procedure which is called either when the user presses the calculate button or hits the return or enter key. What it will then do, it will perform the feet to meters calculation, taking the number of feet from our entry widget and placing the result in our label widget. We specified a text variable options when we created the widget. So we specified that the global feet variable, this variable here, we defined a variable called feet and meters. They are global. So here, so we defined here, you see the global feet variable here. We are using that here as a text variable here. This is where we define the global feet variable. So we're using that. We're using that as the entry. So that will be where they will enter the value in feet. So which means that anytime this entry changes, TK will automatically update the global variable called feet. Similarly, if we explicitly change the value of the text variable that is associated with a widget, the widget will automatically be updated with the current contents of the variable. So we're also doing the same for the meters global variable, which is here, which is attached to this label here called text variable meter. So the same applies to that. So here also we've implemented some error handling with the try and except statement. So whenever you implement error handling, you need to implement a try and an except statement. So in the try block here, we've got the get method, which will get the value in feet, And here is, this is what gets the conversion. We're using the set method to set the value in meters, and this is what it does. This is how it does the calculation based on this. So it will multiply this by the value that is entered, and it will multiply that by this and add this and divide by that. That will give you the conversion in meters. And here, this is any error that occurs, it will capture the error there. Okay, so that is basically the application. And here again, this is, I've already spoken about this, but this here is this tells TK to enter its event loop. This is needed to make everything run. So this is what keeps the application running, by the event looping. So let me save that, and then we can test and run our application. Make sure you format your code properly. If not, the editor will complain. You can see how I've got my code structures. Make sure you've got yours completely structured the same way. If not, it will complain. So I'm going to click on save, and I'll run the application by going on run and clicking on run module. Okay, so this is our application here. I'm just going to type in a value, say 56, click calculate, and you can see this is the equivalent in meters. So the application is working as designed. So that's it for this project. Thanks for watching, and bye for now. Hello and welcome. In this video, we are going to create a times table generator project. This will be an application that will automatically generate the times table. For example, you type into a certain number. If you type in, say, for example, 4 inside an input box, and it will generate the 4 times table for you, and so on. To begin, open up your Python idle, and that will give you this shell here. And the way you access that is via the Python folder, and then just click on the idle. That will give you this shell. So once you've got the shell open, let's create a new file. You go File, New. So this file here is where we will write the code for our times table generator. First thing we need to do is save this file and give it a name. It's going to be in a Python format. So you do save as. It already gives you the file type. It's going to be a .py, which is a Python file. And then make sure you save it in the directory you want. I want to save mine on the desktop. So I'm going to give it a name. I'm going to call it multiply generator. But call it anything you like. The name is really insignificant. I'm just going to call it multiply generator. You could call yours multiplication generator. So yep, so now everything I write here will now become a Python file. First thing I need to do is import a couple of modules I want to use for the program. So the first module I'm going to import is called assist. So you do import space sys. This module provides a number of functions and variables that can be used to manipulate different parts of the Python runtime environment. The next module I'm going to import is called Tkinter, which is basically used to create GUIs. GUIs stands for graphical user interface. So this is Tkinter. I'm going to type in import. So we're going to use that for creating the GUI for the application. So let's define a function that we will use to print out the timetables on the screen. So I'm going to define it. You use the def keyword to define a function. I'm going to call it times table. Times table, and in parentheses and then colon. So that's how you define functions. So next thing I want to start implementing the logic for the function. What I want is that when you enter a number into the application, I want the times tables to be printed out on separate lines. So to do that, I'll do print, and inside the parentheses of the print method, I will add a quotes, two double quotes, and a slash, and an n. What that will do, this will print out each of the lines of the timetables in separate lines. Next, I want to create a loop that we will use for a range of times table to generate. So we want to generate from 1 to 12 times table. So we need to create a loop. So I'll use a for loop. I'll say for x, represent where to start. I'll say for x in range, and inside that parentheses I'll specify the range. So I want 1 and 13. And what that would do, it will generate a range from 1 to actual 12. So next I'm going to create a variable that will get the inputs. So you say m, I'll make the variable m, and I am going to indent this, and the variable I'm creating will be m. I'm going to set that to equals to an integer. Integer basically is a number, so I'll set that to equals to int, which means integer, and inside that integer I'm also going to attach the get method. So I'll say enter table, and enter table, and then I will attach a get method to that. So this is what, when you enter a value, this is what will grab that value. I also want it to print on separate tabs. So to do that, I do print, and in between the parentheses I will specify some stuff. So here I do single quote, lowercase t, single quote, comma, the variable x for that x value, comma, and then we say for x value x, comma. So this line of code here will print separate tabs. You can see I'm representing each of this value x here in this range, and this integer here that will be passed in. So I'm going to wrap this lecture here, and we'll continue in part 2. In part 2, we will set the position for the frame of the screen for the application, and we will also set labels and buttons. So see you in part 2. Thanks for watching. Hello and welcome to the part 2 of creating the times table generator. In this part we will complete the project. So I'm going to create a variable called multiply and set that to equals to a tk method. I've already imported the module, so I'm going to use the functions from the methods from within the module. So the name of my variable is going to be multiply. It's going to be a global variable, multiply, that will be available throughout the application. I'm going to set that to equals to tk, it will be lowercase k. So we're setting that to the tk method. Next thing I want to do is set the position of the frame for the screen resolution. So I'm going to position it for 600 by 150, and I'm going to use the geometry method, which is a property that comes with the grid method. So I've added the 2 lines of code here to save time. This line of code, basically this will set the position of the frame for the screen resolution, and it's going to set it to position at 600 by 150. That's what the value is. And then here I'm using this to set the title. So the title for the application will say multiplication table. So I've created a variable here called enter table, and don't forget I've used this variable here. I've used the value there, so I'm creating it here and I'm setting that to equals to the string var. This means that this will accept string values. Next, I'm going to create a few labels and an entry widget that you can use to type in the times table number you want to generate. So here I've created some labels here, and this label here, label 1, will be for the multiply, and the text will say multiplication times table. This will be the font property. The font size will be 30. The foreground color will be black, and I'm applying the grid method here with a row of 1 and a column of 6. Here for this label also, for the multiply text, this is part of it. We're attaching a grid method for a row of 2 and a column of 6. Here I've got the entry widget. Again, we'll call in the multiply and applying a text variable here that will accept the input, and I'm setting that to equals to the enter table, which is this here. I'm justifying that to position it to the center. Again, I'm applying some grid here with 6 column, 4 rows and 6 column. For this label, this will just be the text for the input. Next, I'm going to add a button that will have the time symbol on it. This button will be the button you click once you've entered the value for the timetable. For example, if you enter into this entry widget here, if you enter a number of 5 and press the times table button, it will generate 5 times table. So I'm going to add the button here and also create one label after the button, and I'll also create a quit button that you can use to quit the application. Okay, so I've added a button here and a label and a quit button. So this is button. The button will say times table. This will be the text on the button, and this is a command. I've set the command to equals to times table. I've attached the grid method here, and the grid here will have a row of 5 and a column of 6. And here again we've got a label. This label also, we've got a grid method attached to it, a row of 6 and a column of 6. And this will be the button for the quit, and this is the logic for it. Inside that we'll have this text that will say quit. This is what will appear on the button. It will say quit. The foreground color, I'll make it red. You can make it any color you want. And this command here will this method.destroy is what will get rid of the applications. Once you click on the quit button, it will attach to this method destroy, and that will escape or quit the application. This again, I've applied the grid method, so this button will show on grid row number 7, column number 6. So that is it. I just need to add the main event loop that will keep the application running. So to do that, I just type in multiply. This will be the main loop that will keep the application in the event loop. I'll keep it running. Once you exit the loop, then once you click the quit button, it will exit the loop. So I'll say multiply dot main loop. Okay, so that's it. That should be it. I'll click save and we can test. Make sure you've got your code indented the way I've indented mine. If your indentation is out of line, the editor will complain and will not run your code. So if you do have any complaint, it will be on this side. It will show inside the shell. So this is where any errors will show. So just make sure you have your code indented the way I have indented mine. So let me quickly run through the code again before I try and test it. So we started off by importing the sys module and the tkinter, and then we defined a function called times table, and we've got the print here. This basically it will be used to print separate lines, and then we've got a loop here. We'll use this loop for a range which it will generate in times table. So it will generate times table from 1 to 12. Here we've set a variable called m, and we'll set it to integer, and this value here, this here will print on separate tabs. Here we'll set in the multiply variable to equals to the tk method. Here we are setting the position of the frame for the screen resolution. We've set here is 600 by 150. This will set in the title for the application. It will display multiplication table on the title, and here we've got a variable called enter table, which we've used here, and we're passing it. We're setting that to equals to this string var method, which will accept strings in value. And here are just various labels we've created for the application. This is a button that this is the button that will do the generation once you click on the button, and this command will execute. And here is a button that will quit. When you click on that button, it will call this option here, this command here, which contains a destroy method that will exit the application. And then here we've got the main loop. The main loop is always the last in the code, because this is what keeps the event in the loop, keeps the code running. So that's it. Let's save that and let's test it out. So I click run module. Okay, and when the module runs, this is where I enter. Say for example I want 7 times table. I type it in there and I click times table. It should generate. So there you go, it's generated it. So it gives you the times table there. Let me just bring this here a bit so you can see that. So if I type in, let's type in a different value, let's say 5 times table, you can see it's generated the 5 times table. Let's click on 6. You see I've got 6 times table. Let's do one more. Let's do 8. And you can see 8 times table. So we've got the application working as designed. So you can always make improvements to it. So if I click on this quit button now, it will call this destroy method and the application will exit. So this concludes the project. Thanks for watching and bye for now. Hello and welcome. In this lecture, we are going to get the computer to generate random numbers using Python. To begin, let's open up our Python idle. So you go to Start or Program, click on the Python folder, and then click on the Python idle. And this should launch the idle. So we'll now open up a new file and go File, New File. And I'd like to save this file. So save it as, I'll save it to my desktop. Notice it's got the right extension here, which is a Python file. So I'll just save it as random numbers and click save. So this is a file. I've got it saved now as random numbers.py. All right, I'll just move that here a little bit. Before we can generate random numbers, we're going to use a Python module called random. So Python has different modules that you can use for different things. So I'm going to use the module called random. Before I can use it in my program, I need to import it. So to import it, you just type in import followed by the name of the module, and the name is called random. Okay, so it's now been imported. I just save my file. I just save. So I've now imported the module. The next thing I want to do, I want to generate some random numbers. So I need to specify a range. Okay, and I'm going to be using a for loop as well. So I'll just do a for, this is a loop, for I will be the range, for I in a range. And then I need to specify the range. So I'll say from 1 to say 27. Okay. So I want the computer to generate random numbers from 1 to 27. Next thing I need to do, I want to print it. So I'll type in print. And then followed by the word random dot rand int. Int means integer. Integer is a number, and then I'll pass in the values. So I'll go 1 to 27. Okay, so I'll save this, and if I run this module here, the computer should generate random numbers between 1 and 27 inside the Python shell. So I've got that saved. I'll just go run. Oop, okay, I've missed out the syntax somewhere. Let's see what's gone wrong. Oh, I didn't need the extra parentheses, that's why. I need to put a colon there. I'll save that and run the module again and go run, and you can see it's generated the random numbers here for me. So that's how you generate random numbers using Python. Thanks for watching. Bye for now. Hello and welcome. In this lecture, we are going to create a number guessing game. What will happen is the computer will generate a random number, and you, the player, will try to guess what number it is. To begin, let's open up our Python idle. So we go to our programs, click on the Python folder and click on the idle. And once the idle is launched, you just open up a new file, go File, New, and we'll save this new file. We'll save it as a Python file on the desktop. I'll call it Number Guessing Game. Okay, and click Save. So we've got that saved. Okay, because we want the computer to generate a hidden random number, and then we or you, the player, have to try and guess what number the computer has generated. So you have to keep guessing until you get it right. So the module we will use to generate random number is called random. Before we can use it, we need to import it. So I'll type in import random. What we want to do as well, we want a way where all the guesses that the user makes is also stored. So when they finally guess the number right, it will display all their guesses, and it will also display a report showing how many attempts it took for them to get the right answer. So to do that, we're going to create a list. A list is kind of like an array that will store the guesses. So I'm going to create it. I'll call it guesses. So this will be the list. For now, set it to an empty array. And that's how you create an array. So this is where the guesses will be stored. Okay, so I need to create a kind of variable that the computer will use to store random numbers. So to do that, I'll call it my computer. And I'll set it to equals to random dot rand int. The int means integer. So this, I'm telling the computer to generate random numbers, and I have to specify the range of numbers. So I'll say generate random numbers from 1 to, say, I'll make it 70. You can make it any number, it doesn't really matter. It will work for any number. So the computer will generate random number between 1 to 70. So the user will have to try and guess which number the computer has generated. So that's the variable for the computer, and then there has to be a way for the player to input the number. So to do that, we create another variable called player, and we set it to equals to integer, because they'll be entering an integer, and will also be an input. And then we specify the text. We'll say enter a number between 1 to 70. Okay. So we want all the guesses the player makes to be appended or added into this array here, this empty array we've created. So to do that, we need to do guesses dot append, and then we'll pass it the name of the variable, which is player. So every guess that is made, it will go into this variable, this list here called guesses. Next thing I need to do is find a way of checking if the number, to try and help the user guess right, we need to find a way of checking if the number they have entered is either too high or too low. We're going to achieve that using a while loop. To save time, I have implemented the while loop already. I'll just explain the code to you. So this is where the while loop starts. So what this is doing is checking for some conditions here. So it's saying while the player, while the player, the number the player has selected, okay, is not equals to the computer. So the number the player has typed in, if that's not equals to the number the computer has secretly generated, then what it will do, it will check if the number the player, as long as this condition is true, it will check this. If the number the player has entered is greater than the number secretly generated by the computer, it will print a message saying the number is too high. So this will kind of like give the user a clue as to how close or far off they are to the number the computer has secretly generated. So it will print too high. However, if the number is low than the number the computer has generated, if it's lower, it will print the number is too low. Again, it will start the loop again here. You notice, and here it will do the same thing as done here. It will type in any number between 1 to 70 in order to guess the number the computer has generated. So every guess that the player makes will be appended to the list. So the loop again starts here, and the loop will keep going on until the number is guessed right. So when the number is correctly guessed, these reports will be printed or generated. It will print, you have guessed right, good job. It will also print how many guesses it took the player. And we've used this I here is the counter, is the indicator is the counter, and this is the percentage of the guesses. This here is used to identify the guesses, and the length here, this is the length of the guesses. So it will list all the guesses based on this length here. It will also then print these were your guesses. It will print the guesses based on this, and it will print all the guesses. Okay, so I'll get that saved and we'll run the module, see if that works. I'll go run module. I've got some error here, indentation. It doesn't like the indentation here. So what I need to do, I need to bring that here a bit. It's a bit fussy with indentations. So I'll go save. I'll run it again, see if it's happy this time. It seems to be happy. So I need to enter a number between 1 and 70. So I'll go 30. So it's too high. Okay, so that's giving me a clue. I'll go 20. Too low. So 30 is too high, 20 is too low. So it's got to be between 20 and 20 something. So I'll just put 25. Oh, great stuff. So I've guessed it right. It says you have guessed it right. Good job. It took you 3 guesses. These were your guesses. So these were my guesses. I guessed 30, 20, and 25. So that's it. So that's how you will create a number guessing game in Python. So this is the file here that we have generated. And this is the actual program. So this is what we'll run. Thanks for watching. Bye for now. Hello and welcome. In this lecture, we are going to create a program in Python to detect and remove any vowels it sees in a word or a sentence. So every letter in the alphabet is either a vowel or a consonant. So examples of the vowels are A, E, I, O, U, and sometimes Y. The Y becomes a vowel when it is used in words like cry, sky, fly, or Y. And in other circumstances, it is also used as a consonant. For example, in the word yellow, yacht, yam, or yesterday. So to begin, let's open up our Python idle. So go to Start, All Programs, and look for the Python folder. And just click on the Python folder and select the Python idle. So click on that, and that should launch the Python idle. So you should have an idle looking like this. So I'm going to open a new, I'll go File, open a new file. So I'll just bring that next to it a bit. Just bring that there like that. Okay, so we've now got a new file. So the first thing to do is to save this file. You go File. I'm going to save it to my desktop. So I'll do Save As. And I'll just save it to my desktop. I'll click Desktop. And I'll just call it. Notice Python files are saved as with a .py. So I just name it Removing Vowels. And it will be a .py file. So I click Save, and that should save the file on my desktop. The first thing we're going to do is create a constant, but call it a variable instead. So we'll call it vowels, uppercase, and then set the value in parentheses, open and closing parentheses, and in between the parentheses we will place the various vowels and enclose them in quotes. So the first one will be an A. We'll make it lowercase, and then we'll separate each of the vowels with a comma. The next will be an E, a comma, and then an I. Okay, now that we have specified all the vowels, the next thing we need to do is find a way for the user to enter a message. So we'll come tab down and just type in message, because we want it to be a string or a text. So we'll type in message equals to input. And then in parentheses, we enter the text that the user will see. So we'll say enter your message. All right. The next thing we want to do is create a variable that we will use to store all the consonants once the vowels have been removed from the word or sentence. So I'll call it new underscore message, and I'll set the value to be an empty string at the moment. To save time, I have written some more code here. So here I've written a for loop. So what would happen when the user types in the message, this for loop here will go through the message and check if there's any vowels there. So these vowels here that have been listed in this is a kind of array. It's called a tuple kind of. It's a kind of an array. So it will check what the user has typed if any of these vowels is there. If it doesn't find any vowels in there, it will attach the new message and the letter to this new message variable. If, for example, however, it finds a vowel, any of these vowels listed in the message, it will print the letter from the vowel and also this text to say I am a vowel. And then whatever is left after the vowel has been taken from the sentence, it will print what is left of the word, which will now become a consonant because all the vowels have been stripped out. All right, so I've got it saved, and I'll just click on run. If I click on run, I click on run module, and you get a thing here. So this is where you enter your text. So let me type in something. Let me say, how are you? I press enter, and notice it has stripped the vowels, taking the vowels out of it. So when you run the code, you should get it. It should print, for example, it will print out all the vowels it has removed and print the word, print the consonant, which is what is left after the vowels have been stripped. There's something I need to highlight here. When you are writing the code, if you notice, the if statements here have to be indented on the same line, because if this indentation, if for example this is like that, this piece of code here will not run. All right, let me just try that, and you can see I do save and I run the same code again. Oops, it's saying here, it tells you the indentation does not match. So you have to make sure they match on the same level. Very important. Okay, so make sure the if statements align, they are on the same line of indentation. So I've made that the same now. If not, this part of code will not execute. That's what happened here. When I ran it here, notice that it only executed this message once the vowels have been stripped, but it did not print out the actual message which I instructed it to do here because the indentation was slightly out. But once the indentation has been aligned, the messages were printed properly. Let's run one more. Okay, so let's type in the fast red fox jumped over the lazy sleepy dog. There you go. So it has stripped stripped out all the vowels and printed what's left after the vowels have been stripped. So what is left now is the consonant. That's this word here. All right. So in this lecture, we've been able to create a simple Python program that removes vowels from a sentence. Thank you so much for watching, and take care. Try and practice a few more. Notice when you save your files, you've got to save it as a .py. So this is a program here I've saved, and it is saved as a .py file. Okay, take care and bye for now.